Welcome to video 2 in a series of introductory videos for InventorCAM. In this video, we'll be covering tool tables. So the tool table is the definition of the tools you're going to use in your operations. You can either define them before you even get to a part, or you can define them while you're inside of a part, inside of an operation. So let's start by defining them before everything. Let's just set some default libraries and we can take it from there. So let's go to New. And you choose which module library you want to create. Milling, turning, mill turn. Essentially all it is the type of tool. You're either going to just make milling tools, just turning tools, or you can make a mill turn library for your mill turn module, which has both types of tools. So I'm going to click on that one just so we can do both. It pops up this window here just asking me what I want to name the table. So let's just call that intro tool table. So that'll be the name of the folder when I go looking for it. That'll be the name of the tool table file that has all my definitions. I can relate it to a post. So if I click on related machine, I can choose from these default posts or your entire post list. And what it does is it basically ties it in so that when you select that post in your CAM part definition, the library that you're first able to select from, or the first library that will pop up in your library list, will be this one. If I leave it blank, it just means that it's not tied into that one specifically. It won't be pulled when I choose that post. And then where I'm saving it, this should be the default library location that we saw in video 1. But if it isn't, or you want to browse and save it to a different location completely, you have the browse button right there. When I click OK, it opens up this table. And this is your global library. You can see that it has the name that I just created. I can still, again, relate it to a machine if I like. And I'm going to add tools to this empty list here. In the bottom left corner, we choose the type of tool we'd like to create. So if this was just a milling folder, milling tool table, it would only have this icon. If it was just turning, it would only have this icon. Since it's a mill turn, it has both. Let's start with a milling tool. So I click on Add Milling Tool. I choose the type of tool, and you can see that there's the various shapes in here. So whenever you choose one of these shapes, it opens up another window right here where you can give it the actual dimensions of that tool. In this case, I chose a flat end mill. It's a really simple one, so we'll just go through the very simple definitions here. We have the diameter, shoulder diameter, and the arbor diameter. Overall length, how far the tool is sitting outside the holder. And in this section here, it actually has to be decreasing. So if that's the overall length, I say how much is being held outside the holder, which means it's actually, in this case, being held by only ½ inch. Shoulder length, cutting length, or the flute length, and then number of flutes. Now, all of that is shown here in this dimension drawing, so you can get an idea as to what how that thing is shaping out. With the tool picture, you can actually see the shape itself. So the yellow portion represents the cutting surface, which is the cutting length. So let's say if this tool only had a ½ inch cutting length, as soon as I change that, you'll see that the yellow area shifts as well. If I change the arbor or the cutting diameter, you would see that that changes there as well. So this is just a matter of defining the dimensions of the tool. So you can define this little representation here. This is actually what will be used in your cutting surfaces, how much material is being removed. In the simulation, it will show using this tool. Under tool data, you can plug in your default feeds and speeds, and you can define them either in metric or inch units. So much similar to what we saw in video 1. Whatever you're defining here is just simply a placeholder. This is the definition of the tool for its generic use. Inside the part files, when you select this tool, you'll have the opportunity in the operation to change the feed and speed, the step down, step over, all that stuff. But specifically, whatever information you're plugging in here is simply just placeholders so that when it's imported into an operation, it automatically imports those in there. So you can leave these as these default values here, or you can plug in specific feeds and speeds so that the most common ones you use, let's say it's related to the most common material you're using, plug that in here. When you choose this tool, it'll auto-populate with whatever you've plugged in here. Under iData is related to the iMachining operation. So if you're going to use this particular tool in iMachining, you can default the iMachining material definition. For the purposes of iMachining, the more information you provide, the more optimized the toolpath gets. So in this case, what is this tool made out of? You have the options here. the flute angle, the helical angle of the flute. You can choose from these defaults here, or you can actually hand type in a odd, let's say we had maybe 37 degrees. You can plug that in there. Default machining level. Some of this is actually more related to iMachining, so we're going to cover that in the iMachining video, but you can set your default level here. And for this particular tool, if it can only handle certain chip thickness, you can check that box and plug that in there. If you'd like to define a holder for your tool, InventorCAM comes with a bunch of default shapes, default holders, or you can define it using an STL file. You can get an STL file from your supplier. Most suppliers nowadays do have the 3D model in some format, but if you can convert it to an STL or it comes in an STL, you can use that to define your holder. And we actually have covered that in a tips and tricks videos on the YouTube, on our SolidCAM University channel on YouTube. If you don't have a tool that follows any of those shapes that we defined in this window, then you can actually go to shape and define the tools a little somewhat further. And then that is also covered in a tips and tricks video on our YouTube channel. So that is a milling tool. Let's see how you define a turning tool. So you click on Add Turning Tool. And there's actually two types of definition, the composite tools and the solid tools. Let's go with the composite tool to start. And it's actually pretty simple. It's all based off of some standard information. For instance, here you can see that your insert is defined by its name. So just the common nomenclature you find in the catalogs, just build your name here. So let's say we do a really common insert, the CNMG 432. So you have C, N, M, G, 4, 3, 2. So I built it from the pull-down menus. You can see that the name is complete over here. So really easy to define the insert. Everything else on here, you can define your edge formation, if it's right hand, left hand, or neutral. And you even have the ability to just define the insert if you don't want to go ahead and define the shank. And all that's going to do is if you look in the tool picture, instead of having the shank, we can just say it's insert only. This can be used if you don't have the ability to define a standard shank. Let's say you're using a one that's been reground, so it has better clearance. It's maybe a custom shank that doesn't pop up in our list that we're about to look at. You just need to just define the insert just to get going. You know that shank's going to clear, so just use the insert. You can just click insert only, and that's it. You can also use this if you have that custom STL holder I mentioned a second ago. That way you can just bring in that custom holder as a shank, and then you can just place your insert using some of the placement options in the STL options, and then you'll have your custom-made holder. Okay, so let's go to shank. So you can see shank, again, simple pull-down menus. We have our clamping. The insert shape comes from the definition that we just did. Insert lead angle, again, customization there, so you can see some default angles there. The cutting direction comes from our insert definition, and then the rest is just dimensions of that particular shank. So you'll see on the right side there, there's a dimensional drawing showing you some of those values there. Again, this is just to define a standard shank. There's nothing customizable about it. It's just if it matches any of those shapes that you find in those menus there. But let's say you had a very oddball custom shank, custom tool. That's where the solid tools come in. Let's make another external roughing tool. And you'll see from this right window here, it's got a dimensional drawing. You define each one of those dimensions to define your tool. It might look similar, but that's only by default. But if you play with these values here in either metric or inch, you can get it to look like whatever custom tool you're working with. If it's a solid carbide boring bar, or if it's just a weird insert that sits inside of an STL holder, you have the ability to define whatever type of tool you're working with inside of InventorCAM in these windows. So I define my library here. I can click on Save and Exit, and it saves it as a global library. And we can pull from those global libraries inside of our toolpath. If I want to cherry pick from other global libraries, there are some libraries that actually come with InventorCAM. You can go to Import Tool, and you can choose from the global libraries that come with InventorCAM. You can see that there's a list here. Let's say we go to the Tools Master List for aluminum. From your global libraries, you'll see that this list probably has maybe thousands of tools on it, or you make your own and you've filled up that list as well. You can actually filter through the libraries. So under these headings, let's say we go to tool type, and I'll just click on that triangle there. That is our filter. I can just say clear all. I'm only looking for a flat end mill. So it filters the entire list to just show me the flat end mills. And I'm looking for a particular size. Let's say we're looking for a 1/2 inch end mill. Again, I'll go to the triangle and I'll say I'm only looking for everything from 1/2 inch down to, let's say, just 0.499. So everything on this list that filters that falls under those two filters, and you can see here that they've colored them blue, so I can tell that those filters are applied, are these guys here. And then from here I can go even further. I can say, okay, well, I'm looking for something that has the longest cutting length. Maybe that's this guy right here. And then it shows me a little tool picture representing that. So these are just predefined tools. All those definitions we plugged in earlier for tool 1, it's similar here. It's a flat end mill. It has the same dimensions. If I want to look at those dimensions, I can click on this guy here and see all those dimensions. It has a tool number, which I can change if I like. It has a particular description that'll pop up in my tool list, anything like that. So anything here will be automatically added to the library I just created. And I can say, from the white arrow, just import the tool. I can tell it how to import it as well. So either import it with the tool numbering or just to the next free tool number. So if I import this one, it actually becomes tool 4 because that's the next free number. Or I can just add it to my tool storage. In this case, it's not sitting in the turret. It's actually sitting in tool storage, meaning that it's not assigned to the turret. I just added it to my active tool library or the library I'm currently editing. And then that way I can just grab it and switch it around if I need to. It's just a way to add it to this library without actually giving it a number that might overlap or anything like that. The blue arrow, however, is to import everything in this library. And when you're working with these global libraries, you might get confused because the filters applied. It might just be applying these guys. This actually applies to everything in that library. So the use of that button is more for if you've defined the complete library list of that particular machine. Let's say you're working on a machine that has a tool changer that can hold 20 tools. And you defined a library named for that machine. Let's say it's a Haas VF4. You go to your Haas VF4 library. You've defined all 20 tools that are on that mill. And then the next part file you're working on, you want to import all 20 tools because you know you're eventually going to use all of them. You can click on this blue arrow to import everything. So let's say I did my cherry picking, and now I want to save this as its own library. Well, while we're in this window, I can click Save and Exit, and that's basically what I've done. I've just saved the global library. But when you're in a part file, you can define tools as well, and it actually ends up being a little different. So let's say we go and open up a part file. So while we're in a part file, I can go to my tool table, and I already have a couple of tools here. These tools were defined inside the part file. They only exist inside the part file. This is what we call the active tool library. This is a way to just add tools while you're working, and they stay only inside this part file. If I want to grab tools from those global libraries I just created, I can go to Import Tools like you saw me do before. And then there's that tool table I just created. And like I said, if I want all 4 tools to be added, let me just click on blue arrow, and all 4 tools have been added. So while we're inside the active tool library, we can take a look at the dimensions of the tool. We can make changes, so you can see that this is tool 1. Those are both tool 1. That probably doesn't make any sense, so I can go in here and I can change these. Let's say that's tool 10. So once it's imported from the global library, I have the ability to change everything. I can even go to tool data and change the fuse and speeds if I want to. So they're just placeholders brought from the global library into the active tool library in a CAM part file, and then they become the full use. If these guys are out of order, I can just reorder them right here. I can say renumbering in operation sequence or tool sequence. In this case, I'll just go tool sequence, and as they sit in my library, I put them in order. Let's say this library is a library I've created as I went along. Each operation, I just made a tool inside my CAM part library, and like I mentioned before, it only stays inside the CAM part unless I do this, unless I say export. And I can export everything, or I can export just the ones I selected. Once I click export all, it asks me where I want to save it. And it actually defaults to that folder location we talked about in video 1. So that pretty much is everything to do with tool tables. If you have any questions on this or anything else from SolidCAM, just give us a call at 1-866-975-1115, extension 2. You can send us your parts or your questions via the ticket system at solidcamsupport.com. And stay tuned for the rest of the videos in this introductory series. Thanks for watching.